Hey everyone, you are kindly welcome to this presentation. This presentation will be mainly briefing you about the topic polymers, which comes under the subject Applied Chemistry for CSE stream and which has the subject code BCHE202. And for the one who don't know me, myself, Titrashriyam, my USN is 1VE23CS042. Currently pursuing my BE in Sri Venkateswara College of Engineering in second semester from the Department of Computer Science and Engineering. Guys, please make sure that you like this video. Yes, the selected topic is polymers, which is very common term or frequently used term. So the contents of this topic is initially the introduction and classification of polymers, mainly based on source and as well as based on structures, and finally the applications of polymers. Entering into the presentation, initially the introduction. Polymers. Polymers is a term which is obtained from Greek word where poly is nothing but many and mers means parts, or I can say it as units. So polymers can be defined as they are the macromolecules, or I can say it as complex molecules. They are obtained by union or combination of some simple molecules, and those simple molecules are referred as monomers. And it can also be defined as it is one of the macromolecule. It is made by continuous repetition of some simple molecules called as monomers. We have to know the definition of monomers. Monomers can be defined as they are the simple molecules. They combine with each other and lead to the formation of polymers. I can say it as monomers are the building blocks of polymers. So it is said that polymers is a term which is used as synonym for plastic, and it is important to note that all plastics are considered as polymers, but not all the polymers are considered as plastic. Here I have selected one equation, that is ethylene is one of the monomer. Such n number of ethylene monomers combine together and they lead to the formation of polyethylene, which is considered as polymers. So there are some examples of polymers like cellulose, wood, rubber, proteins, enzymes and DNA. Moving to the next, some more examples of polymers are Teflon, which is used for making some kitchen products, rubber, plastic, polyester for making clothes, sugarcane, and some of the molecules which carries genetic code like DNA, RNA, and wool. There are many such examples of polymers. So by visualizing this picture, we can understand that many number of monomers they combine with each other and they lead to the formation of polymers. So the process of obtaining polymers from monomers is known as polymerization. So I can define it as the process of linking up of monomers to form polymers with or without the elimination of byproduct. Here I have chosen one example, that is hexamethylene diamine and adipic acid. They are the two monomers. They combine with each other and they lead to the formation of nylon 66, where nylon 66 is a main product, or I can say it as polymers, and H2O, water, is the byproduct. Classification of polymers. Generally, polymers are classified into two types. One is organic polymers and the other is inorganic polymers. Simply, it can be said that if the molecule or if the polymeric molecule, if it contains carbon atom in its structure, they are classified under organic polymer. If the molecule that does not contain carbon atom, then they are grouped under inorganic polymers. Some of the examples like cellulose, proteins, polyethylene and nylons. These are the examples which are considered under organic polymers, which means these molecules have carbon atom or carbon chain in its structure. When it comes to inorganic molecules, the examples are glass and silicon, which means they doesn't have any carbon atom. When it comes to the source-based classification of polymers, they are classified into three types, mainly natural polymers, synthetic, and even semi-synthetic polymers. We know that polymers are the macromolecules. They are obtained by the combination of simple molecules such as monomers. So, if the polymers are obtained from the nature, naturally if they are obtained either from animals or plants, then they are said to be natural polymers. If any modifications are done for natural polymers, then those polymers are referred as synthetic polymers or semi-synthetic polymers. Some of the examples for natural polymers are cellulose, pectin, starch, and chitin. Synthetic polymers examples are polyesters, polyethylene, polythene, and etc. When it comes to the definition, natural polymers can be defined as polymers which occurs naturally in plants and animals. Examples: proteins, cellulose, starch, and rubber. Semi-synthetic polymers, they are the polymers which are obtained by chemical modifications of natural polymers. Examples: rayon, cellulose derivatives. And synthetic polymers, they are man-made and they are typically or they are usually derived from petroleum and natural gas. Example: nylon, polyester, and polyethylene. When it comes to structure based classification of polymers, if any polymers, if it looks like long chain like structure and which are usually straight, then they are classified into linear polymers. Examples: polyethylene, PVC, polystyrene, and polyamides. And if the polymers, if it has long chain like structure with some branches, then they are grouped as branched chain polymers. Example: glycogen and starch. If the polymers have long chain-like structure and they are linked together at various points, I can say it as if the polymers looks like network-like structure, then they are classified as cross-linked polymers. Example: bakelite and melamine. I have said that Teflon is an example of polymers. Its application is for making kitchen appliances, and even polystyrene. It is used for making clothes and in clothing industries. There are such applications of polymers. Usually, the applications of polymers lie in medical applications, nano industries, electronic devices and batteries, membrane and plastic industries, sensors, and even some polymers act as catalysts for chemical reactions. Let me brief you some of the applications of polymers. Initially, in medicine industries, many biomaterials, especially heart valve replacement and blood vessels, which are made up of polymers like Tacron and Teflon. In consumer sense, some of the plastic containers of all shapes and size, and usually they are lightweight and they are economically less expensive when compared to traditional containers. In pharmaceutical industries, polymers are also used in tablets as coating materials to mask up unpleasant drug taste and to modify drug release characteristics and to enhance its stability. In engineering field, basically group of plastic materials are said to be engineering polymers. They are used in replacing traditional materials due to its lightweight, hardness, and some other properties. In electronic industries, they are widely being used of variety of applications, for example for cable insulation, molded products, and circuit board. And thank you for watching this video.